Okay, let's see what is streams. So in Java, input output is handled with streams. So you may ask, what is a stream? So actually you can consider a stream as a sequence of data flowing from one place to another, right? For example, it's useful if you think the stream as a buffer of data going one way to the other, right? So an input stream flows from an input source. That input source can be keyboard, file, or etc. So this stream flows into a program in order to be stored in variables. We also have output stream. So an output stream actually flows from a program to an output destination. This output destination can be screen, file, network socket, right? So as you see, the difference between input stream and output stream is the difference between the source and the destination, right? In Java, we have three stream objects. The first one is system.in. So system.in is an stream object for standard input. The second one is system.out. System.out is another stream object in Java for standard output. And system.er, which is a stream object for standard error, right? So in Java, all of the input-output libraries are stored inside the package java.io. So in a program, in order to use these libraries, you need to keep in mind to import this package. You may be interested to see the classes that exist in this package. So easily by clicking on this link, package 3, you can see the hierarchy of java.io classes. So the built-in stream classes in Java are for processing different types of data. And we have two primary categories. The first one is byte streams, and the second one is character streams. So as you see, byte streams is suitable for streams of bytes and character stream is suitable for streams of character. So let's see what are these classes related to these two categories. The first one is input stream. So input stream is the base class for byte stream input classes, right? So when the stream is in the type of byte, then you need to use input stream for input. The other one is output stream. That's the same as input stream. It's a base class for byte stream, but for output classes. The other classes that are suitable for character streams are reader and writer. So reader is actually the same as somehow input stream. It's for, input, suitable for input, but for character stream. And writer is the same, its functionality is the same as output stream, but it's for the stream of character. Let's see how we can read and write with files. File is a class used for retrieving properties of files or directories on a disk. Right? Objects of class file don't open file or provide file processing features. Text files we have text files and we have binary files. So in text files, what we have is character-based streams. And in binary files, what we have is byte-based streams. We have two types of files, sequential files and random access files. In sequential file, there is no regular record structure. So when you are going to read the records, you need to read the entire file sequentially. But for random access file, the records, accessing the records are different. You can access the records sequentially, or you can access them anywhere in the file. We have four basic classes for file input-output. File input stream, file output stream for byte streams, file reader, and file writer for character streams. So let's see one example in input and output file. So we have the main class, so public, static, void, main, string args. First, we are going to declare input and output file streams. And we are going to initialize them to be null. So, file input stream FIS is a file input stream with the value of null, and file output stream FOS is the file output stream with the value of null. Then we are going to check the usage. So if args dot length is not 2, we will print the message. So usage Java for example byte stream from file to file. And then we exit. So system dot exit, right? Here we are going to check an exception, file not found exception. So if we don't find this exception, for example, we are going to try and if we find this exception, then the catch statement will be executed. File not found exception. So if this exception has not occurred, then we are going to first create the file input stream. File input stream is going to be new file input stream, new file arg0 then we are going to create file output stream if the file does not exist, right? So file is going to be new file. So we are creating an object of the file here, and then we check if the file does not exist. So if file dot exists, then we are going to print the message file already, for example, with this number already exists, right? So file args1 already exists. And if a file does not exist, then the else statement is going to be executed. So file output stream, or FOS, is going to be, as you see, we are creating a new object of file output stream. Right? So if we want to see from the first, so we created one file input stream, initialized it to null, one file output stream, initialized it to null. Then here we check, as you see, the number of arguments for input output, right? If is not 2, then we are going to print the message, this message. Here we check the exception of file not found exception. So if we don't catch this exception, then we are going to, as you see here, create a file input stream, an object of file input stream, right? An object of file, then we check whether file exists or not. If it exists, we say yes, it already exists. If not, then we are going to say, for example, file output stream is going to be an object of file output stream, an object of this class, right? And if we catch the exception, then what we are going to do is we are going to print file not found. System.out.println file not found. Right? And if we catch the input output exception, we are going to print system.out.println the message for input output exception. So .get message, right? And finally, anyway, if this part is going to be executed, so Again, we are going to check the exception for input-output exception. So if this exception does not happen, then we are going to close our files. So if is not null, then we are going to close this file. That's the same for FOS, right? And if this exception happens, we are going to say system.out.println. We are going to print the message EX, right? So as you see in this example, what we did was we declared an input and output file streams and initialized it to be null. And then, as long as we don't have the exception of input-output exception and file not found exception, what we do is we are going to initialize, we are going to assign value to these file input stream and file output stream. So file input stream is going to be an object of the class file input stream that as an input argument is going to get an object of the class file, right? So actually, by this, what we do is that's an object, right, that gets the input from the user, right? And then we also assign a value to file output stream. So if file output stream already has a value, we will print this message. And if it doesn't have a value, then we will assign a value to this one as well. So let's see what is a buffered streams. Buffered streams help increase the efficiency. So in buffered stream, we have the buffered array of bytes or buffered array of characters. There are 4 classes for buffered stream as you see here. First, buffered input stream, buffered output stream, buffered reader, and buffered writer. The first 2, buffered input stream and buffered output stream, are for byte streams. Buffered reader and buffered writer are for character streams. In fact, buffered streams are used to add functionality to other streams. For example, To apply buffered streams to file input-output, we can create file streams and then wrap them in a buffered stream object, as you see in this example. So first, we have created a file stream by new file reader, and then in the first line, then we have inserted this file stream as the input argument for buffered reader. So as you see, now we have created a new object for the class buffered reader, right? Or in the next line, we first have created the file output stream, right? And then inserted this object of file output stream as an input argument for buffered output stream. And as you see here in this line, we have created one object of this class and named it as outfile1. Or in the next line, as you see here, in the third line, we have created an object of file reader and then created an object of buffered reader by inserting the file reader as the input argument for this class. So let's see a very simple example, and in this example we are going to read from a file and then write it on the file by making all of the characters uppercase. First, import java.io.star. Let's create the main function public static void main string args. We are going to throw IO exception reader in. So we are going to create an object for the class buffer reader new file reader args0. Then writer out equals new buffer writer new file writer args1. So now in and out are two objects. The first one is an object for the class buffer read, and the second one is an object for the class buffer writer, right? And here we are going to say as long as int read is, we are going to read from in, and then we are going to check the value. As long as int read is not -1, right? Then we are going to change that to uppercase and then write it to the file. What is the file? That's out, right? So out dot write character dot to uppercase char int read, right? So we change it to uppercase and then we write it on output and in the out, right? And finally we will close int and out. Okay, let's see another example. In this example, we again are going to import java.io.star. So public static void main string args. First, we are going to read, right? So reader in is going to be new buffered reader, new file reader, args0. We define a variable int read, a variable string, so here what we are going to do is we are going to read the input and then we want to see how many times a character, a word occurs. So while int read equals int dot read is not -1, then then we want to say if character dot is letter, char int read so if that's a letter, if int read is a letter, then what we are going to do is we are going to add this letter to the word, concatenate this letter to the word. So word plus char int read. Else, what we are going to do is we are going to check whether word equals the input, and if so, we are going to here we need a word count for counting that how many times the word has appeared. So if word that equals, right, word count plus plus. Else, we will set the word to be this space, right? And then again we will check here if word dot equals args1 word count plus plus. We will close in, right? And we will print, for example, system.out.println the word what is that word? We can have it in args1. The word occurred how many times? Word count, right? Times. Right? Okay, let's see another example. In this example, What we are going to do is we are going to list all of the words that are inside the input file and also list the number of times that each word occurs. So we will use java.io.star and we are going to use these two, right? So public static void main string args throws io exception. First reader in is going to be new buffered reader new file reader arg0 int read string word third set word set is going to be new hash set as long as int read is in dot read if the character is a letter, so character dot is letter char int read, we are going to concatenate that to else if the word is not equals to the space, then we are going to change it to lowercase and then add it to the word set. And if it's not the string, then what we are going to do is we are going to add it to word set by first changing it to the lowercase. So word dot to lowercase. Right? Then in dot close, system dot out dot println. There are this number of words different word in this file. Then iterator is going to be word set dot iterator as long as we have the next word in word set, we are going to print it, right? So while iterator dot has next, system dot out dot println right? So that's the example that reads from file, counts the number of words for each word, occurrence for each word, and then we'll print those words as well as the number of occurrence for each word. So here you can see all of these examples. If you are interested to see them, just easily by clicking on each of these links, you can see the examples. Java capabilities. So Java has some new capabilities that are useful for file input output. With Java 1.5, a number of new classes were introduced that actually makes input-output tasks way easier. So two of these new classes are formatter and the other one is a scanner. You already are familiar with the scanner because we have used it several times in the previous examples and previous lectures. So let's see the input and output of objects. First, serialization. What is serialization of objects? It means representing an object as a sequence of bytes that include the object's data, info about the object's type, info about the type of data in the objects. So these are the information that would be inside the sequence of bytes that represents the object. A good point about serialized object is that these type of objects can be written to a file as a single item, and then it can be read from a file and deserialize that. So to do so, you can use these classes: object output stream, object input stream. So here there can be a question that when an object can be serialized. We say an object can be serialized if its class implements the interface serializable, right? And as you see here, we have a very simple example. First, we have defined an object output stream, and then actually we have created an object of object output stream. There are plenty of examples related to this topic that we have gathered them in these two links, so easily by checking these links you can access to the examples and read them to get more information.